Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my dear students? Today, inshallah, we'll start on the last part on our syllabus, which is normal distribution, and this is the first video. We're supposed to start, first of all, from the meaning of the normal distribution. For a normal distribution, probabilities are given by areas under the curve. So basically, normal distribution, sum of the values representing on this curve, and as you see, this is like the y-axis and this is the x-axis, and it's dividing the curve into two equal parts. Area under this curve is equal to 1. So started from the negative values to the 0, this is 0.5. So this line is dividing the area into two parts, or the curve into two parts, two equal parts. So the area of this half is 0.5 and the area of this half is 0.5. So we're going to find the normal distribution using probabilities, which are representing areas under the curve. Tables are provided to help us calculate the probabilities for the standard normal distribution Z. So basically, these tables will be given to you on the final exam, and we use it normally with the normal distribution. I'm going to tell you how you're going to read those values. For example, if you want to find the value of 0.12, so 0.12, we have to look to the line of 0.1, 0.1, this line, and 2. So 0.1, you have to work on the line 0.1. You can use the ruler to show you this. So 0.1 line, and you need 0.12. So this is 2. So this is the value which is required, 0.5478. So basically, this value is representing the area under the curve. So area under the curve is 0 of this value of 0.12. So we can write here is equal to probability of Z less than, this is 0.5478. And we're going to explain that later. Now, Z, which is standard normal distribution, distributed, this sign is distributed on the normal distribution of 0 and 1 squared. So 0 is the value of which we called it mean, and 1 squared, sigma squared, is variance, but the sigma itself is representing something which is standard deviation. So squaring of the standard deviation is equal to the variance. So sigma all to the power of 2 is equal to sigma squared. So sigma squared is variance and sigma is the standard deviation. Then one more time, mu is the mean. Mu is the mean, sigma is standard deviation, and variance is the squaring of the standard deviation, which is representing as sigma squared. Here are some rules that we need to use them if you want to find the probability of some of the values under the curve. Probability of Z less than A. A is a positive value, as you see, so this part is representing the positive and this part is representing the negative. So if you look for the area which is less than, which means at the left of A, so the answer directly is the value from the table. So that's why we'll use the table on the previous part, as we did here. Z less than, this is left of 0.12, so you have to find directly the value from the table. Value from the table is representing the area at the left of the positive value. Now the right is the opposite, because the area under the whole curve is equal to 1. So you're supposed to subtract this part from 1. So probability of Z more than A, which is a right of A, right direction of the value of A, the positive value, is 1 minus probability of Z less than A, or 1 minus the value from the table. Here, less than negative, which is left of the negative value. Left of negative a. So left of negative a is the same as right of positive a. See, they having the same colors. So positive, more than positive, right of positive is the same as left of negative. So you're supposed to do 1 minus the value from the table. Z less than negative a is the same as z more than a. And z more than negative a, the right of negative, is the same as right of negative is the same as left of positive. So it's the table value. Exercise 9a on your booklet, page 179. Use tables of the normal distribution to find the following. Probability of z less than a, 2.12. 2.12 is a positive value. This is the positive side and this is the negative side. So less than positive, which means left. This is left direction. So you're supposed to use the table value. So it's equal to table value. So we have to check the table value. We have to check 2.12. How are you going to find 2.12? We have to look to the 2.0. This is 2.0. And you want to find 2.12. So this is 2.0. So you're supposed to find 2.1. So this is 2.1. And then you have to move 3 units because the first unit is representing 0, which is 2.10. Then 2.11, 2.12. So the answer is 0.9830. 0.9830. More than positive. So this is the positive side and this is the negative side. So more than positive is 1 minus table value. So 1 minus, we have to find 1.25. 1.25. So 1.2 first. Then you have to move 6 units to reach to 1.25. 1.25, 0.8944. 0.8944. Then you can use the calculator to find the answer. 1 minus 0.8944 is equal to 0.1056. Question number 2b, probability of z more than negative. This is the negative side and this is the positive side. So more than negative is the same as left of the positive value. So it's equal to table value. So using the table, 1.68. 1.68. 1.6, and then you have to move 9 units to reach to 1.68, 0.9535. 0.9535. Then question number 2, C, probability of z less than negative. This is 1 minus table value. So I told you before, less than negative is the same as more than positive, which is 1 minus table value. So 1 minus, we have to check 1.52. 1.52. 1.52, so 3 units, which is 0.9357. 0.9357. Now take the difference, 1 minus 0.9357, which is equal to 0.0643. How to find the area enclosed between two values of z? So between two values, whatever, this is negative and this is positive. So you suppose to find the area between A and B, or probability between A and B, using left of the positive minus the left of the negative, or the left of the highest minus the left of the lowest in general. In exercise 9a, page 179, we have this question: probability of 0 less than z less than 1.42. So it's equal to probability of z less than 1.42 minus probability of z less than 0. Z less than 1.42. So this is table value. We're going to use the table 1.42. You know the way now. 1.42 is 0.9222. 0.9222. And less than 0, the area at the left of the 0 or the right of the 0 is equal to 0.5, because the 0 is dividing the curve into two equal parts and the area under the curve is 1. So minus 0.5, then the answer is 0.4222. Here we have to use the same thing. It's probability of z less than 0, because 0 is more than the negative value. So probability of z less than negative 2.30. If you want to represent that on the curve, this is the negative 2.30, and this is the 0. So find this area. So left of the 0 minus the left of negative 2.30. Less than 0 is 0.5 minus less than negative is 1 minus the table value, probability of z less than positive 2.30. Or we can write table value. So 0.5 minus 1 minus less than positive 2.30. 2.30, which is the first value in the table, 0.9893. Then directly use the calculator. 0.5 minus 1 minus 0.9893. So the answer is 0.4893. In this question, we're supposed to do the same thing that we did before, area enclosed between two values. So 2.16 is more than 1.25. So it's equal to probability of z less than 2.16 minus z less than 1.25. Less than 2.16. 2.16 from the table is 0.9846. 0.9846. And less than 1.25. 1.2 first. Then on the line of 1.2. 1.25 is 0.8944. Then take the difference. So 0.9846 minus 0.8944. So the answer is 0.0902. D, same thing. By the way, these two values are the same, but one of them positive and the other one is negative. So we can double the area at the left of 1.57 minus 1. I'm going to show you that. So it's probability of z less than 1.57 minus probability of z less than negative 1.57. If you want to represent that on the curve, suppose here this is negative 1.57 and this is the positive 1.57. It's required to find this area, and this is the 0 in the middle. So as you see, the area from 0 to 1.57 is the same from negative 1.57 to 0. So you can find the area of one of them and you just double it. Or Less than positive is table value 1.57. So on the line of 1.5, then you have to move 8 units to reach to 7. So you have 0.9418, 0.9418 minus, less than the negative is 1 minus the table value. So 1 minus 0.9418. As you see, these two values are the same. So it's like doubling of these two values. So 0.9418 minus 1 plus 0.9418. So it's double 0.9418 minus 1. And you remember that the probability has to be less than 0 and it's not a negative value at all. So it's between 0 and 1. We know that from the semester 1. All probabilities values within 0 and 1. So double of 0.9418, then minus 1. And the answer is 0.8836. The second topic on this chapter, use tables to find Z given a probability. Now we're going to do the opposite as we did in the previous topic. You will have the value from the table, or the value of probability, or the area under the curve, and you're supposed to find the value of the Z from the table. So you have to do the opposite. Now 0.9082, this is less than A. If this value is more than 0.5, so A is positive. Why? Because less than positive is the table value. So A is supposed to be here. And you're talking about the left of this. Left. So directly from the table, we have to look inside the table like this. This is the table. You're supposed to find the value of 0.9082. 0.9, you're looking for the lines which has 0.9, 0.9082. This is 0.9082. So the corresponding value is 1.33. So the value of A is 1.33. Now more than A, and this value is less than 0.5. So the value of A is positive. It has to be here. And you're talking about the right side. How are you going to know that? This is 0.5. Till here is 0.5. So here is still more than 0.5, but this part is less than 0.5. This part is less than 0.5, so A is positive value. You know that 1 minus table value is A is positive probability of Z, or the area under the curve for the value more than positive is equal to 1 minus table value. So here you're supposed to do Z more than A is 1 minus 0.0314. Why you do that? Because you want to reach to the table value. So 1 minus 0.0314, which is 0.9686. Now we're supposed to find the A from the table. 0.9686. 0.9686. This is 0.9686. So the corresponding value of the Z is 1.86. 1.86. For this question, we have to do the same thing. So this is less than, and as you see, the value is less than 0.5. So A has a negative. Why? Because you're supposed to do 1 minus. So you do probability of Z less than A equals to 1 minus 0.3372. A is here, negative A. Less than positive, and the spot, so this is the left of negative. Left of negative is the same as right of positive, like this, because you do 1 minus. And because it's less than 0.5. So 1 minus 0.3372, 1 minus 0.3372, 0.6628. Then A equals to negative. Now we have to find the corresponding value of Z from the table, 0.6682. 0.6628, not A2, 0.6628. This is 0.6628. And the corresponding value is 0 of the Z, 0.42. So negative 0.42. Number 4, A. Area enclosed between two values, one of them is 0. So as we did before, we have to split this probability into two parts. Probability of Z less than the highest minus probability of Z less than the lowest, which is 0, equals to 0.3554. This part is 0.5 and you have to move that to the other side. So probability of Z less than A is 0.8554 because you add that. It was having a negative sign, only move that to the other side. So you'll have the positive sign. So you're supposed to add them. Now less than, and this is more than 0.5, so A has a positive value, so A equals 2. We have to look to this value in the table, 0.8554. 8554. Yes, so 0.8554. The corresponding value of Z is 1.06. 1.06. Same thing here, but now we have between two same values, one of them positive and the other one is negative. So you're supposed to double that as we did before in one of the questions. So you do probability of Z less than the positive minus probability of Z less than the negative equals to 0.5820. Less than the positive, you just keep it as it is, but less than the negative is 1 minus table value, and the table value is representing as Z less than A equals to 0.5820. For these two values, you're going to double them because when you expand the brackets, you're going to change the signs. So you have 2 probability of Z less than A minus 1 equals to 0.5820. You move negative 1 to the other side as positive sign, then you divide both sides by 2. So it's probability of Z less than A 1.5820 dividing 2. We're going to use the calculator. 1.5820 dividing by 2. It's equal to 0.791. And you're supposed to add 0 because all the digits or all the values on the table, all the area under the table, all probabilities values are 4 decimal places or 4 significant figures. Okay. So less than, and this is more than 0.5, so A will take positive. So A equals 2, we're supposed to find 0.7910. 7910, yes. So 0.7910, you'll find it in the line of 0.8, which on the second column. So 0.81, 0.81. Converting random variable into normal distribution Z. We have a simple rule. Z is normal distribution variable. X is the random variable. This is the random variable. Mu is the mean value. Sigma is standard deviation. And remember, sigma squared is the variance. Find the normal distribution when mean is equal to 20, standard deviation is 3, and random variable is 15. So if you want to find Z, converting random variable into normal distribution variable, so you do 15 minus 20 over 3 using the rule x minus mu over sigma. So it's negative 5 over 3, negative 5 dividing 3, is equal to negative 1.666. So it's current 6, so we can write 1.67. N is the Z value, 40 is mu, this is not X, this is the random variable X, mu, 4 squared is sigma squared, which is 4 squared, but sigma is equal to 4 only. So which means if this number without power of 2, you're supposed to take the square root. So use the table, the X is given, but it's going to find Z, so Z is equal to 20 minus 40 over 4. So 20 minus 40 is negative 20 over 4, which is equal to negative 5. Here's another question. 15 distributed in the normal distribution of 30 and 9. So here's 9 has no power of 2. So this is mu and this is sigma squared. So sigma is square root of 9, which is equal to positive 3. Don't write a negative value at all. So for the mu and sigma, they're supposed to be positive all the time. 15 is the random variable, so Z is equal to 15 minus 30 over 3, which is negative 15 over 3. Then it's equal to negative 5. Now, random variable curve. Now, we have exactly the same curve that we talked about before, which is related to standard or normal distribution. Standard normal distribution, which is Z. It's the same as Z. But the difference here, those values will not include at all on the table values. So you're supposed to convert them to be from the random variable to be normal distribution variable to Z. For example, X is the random variable, 10 is mu, and only 2 is sigma, without using power of 2 at all. Because if you're going to use the power of 2, so this is sigma squared, variance. Mu is 10, sigma is 2, so the answer is 12. Mu minus 2 sigma, it's equal to 10 minus 2 times sigma 2, which is 10 minus 4 equals to 6. Mu plus 3 sigma is 10 plus 3 times 2, which is 10 plus 6, then it's equal to 16. So the value in the middle is mu, which is the mean, which represented into Z as 0. And the values are distributed more than mu using sigma. So this is like arithmetic series. This is the first term and this is the second term. So this is like D, common difference is sigma. Mu, then mu plus sigma, then mu plus 2 sigma, mu plus 3 sigma, mu plus 4 sigma, and so on. For the values less than, so you're supposed to subtract sigma. Mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, and so on. Exercise 9C, page 184. If X is distributed in the normal distribution of 30 and 2 squared, 30 is mu, only 2 without power of 2 is sigma. X less than 33, it's required to find probability of X less than 33. So we're supposed to convert it first from random variable to be normal distribution variable. So what you're supposed to do, you do probability of Z less than 33 minus 30 over 2, which is equal to probability of Z less than 3 over 2, because 33 minus 30 is 3. So 3 divided by 2 is Z less than 1.5 or 1.50. Don't think to write 1.5 from the table as 1.05 as 1.05. It's only 1.50. It's not 1.05. So 1.50 in the line of 1.5, you're supposed to take the first value, which is equal to 0.9332. And why you're supposed to take the value from the table directly? Because it's less than positive. Now more than, let's see, is it positive or negative? So probability of Z more than 26 minus 30 over 2. So its probability of z more than 26 minus 30 is negative 4 over 2, which is equal to probability of z more than negative 2. More than negative is the same as less than positive, so its table value. Negative 2 in the table is 2.0 or 2.00. So you have to look for the 2.0 first. On the first column, the answer is 0.9772. Question 3 was the same idea. This is mu. This is sigma squared. So if you want to find the sigma, you do square root of 25, which is equal to 5. Now we have sigma and we have mu. Convert the random variable, which is representing as y here, to be normal distribution. So it's z less than 20 minus 25 over 5, which is equal to z less than negative 5 over 5, which is equal to probability of z less than negative. Less than negative is the same as more than positive, which means left of negative is the same as right of positive, which is 1 minus table value. So 1.00, it's not 0.1. 1, this is 1, whole number. So 1.0, the first column, 0.1 minus 0.8413. 1 minus 0.8413, then the answer is 0.1587. Next question, between two values, its probability of, instead of the y, write z, and then you do 18 minus 25 over 5, and here 26 minus 25 over 5. Why we have to do this step? To convert the random variable to be a normal distribution variable. Probability of 18 minus 25 is negative 7, so negative 7 divided 5 is equal to negative 1.4 or negative 1.40. Less than, z less than 26 minus 25 is 1, and 1 dividing 5 is equal to 0.2 or 0.20. Finding probability or the area between two values, you're supposed to do the highest minus the lowest. Its probability of z less than 0.20 minus z less than negative 1.40. Less than positive is direct from the table, 0.20. 0.20, which is the first column, 0.5793. And less than negative is 1 minus table value. 1 table value, 1 minus table value of 1.40, 1.4 line, and the first column of that, 0.9192. And you can write that directly on the calculator, 0.5793 minus bracket 1 minus 0.9192. So the answer that you're going to get is 0.4985. Question 8. On the same exercise, if x variable distributed the normal distribution of 20 and 12, this is mu and this is sigma squared. So sigma is square root of 12. Find a and b such that probability of x less than a is equal to 0.40. So we're supposed to convert that to z first. Probability of z less than a minus 20 over root of 12 equals to 0.40. 0.40 is less than 0.5. For any value less than 0.5, you're supposed to do 1 minus 0.40, which is 0.60. Or we can write it as 4 decimal places or 4 significant figures. Less than, and this value now is more than 0.5. But in general, less than, and the value is less than 0.5, so this value has to be negative. But let's see. Now we have to find 0.6 thousand from the table. Sometimes you will find some of those values not in the table, so you have to take the least value or the closest value to the area or the probability which is given to you. 0.6 thousand, it's not in the table at all, but we have something which is very close to that. Let's see the least value, negative 0.5832, 0.5871, 0.5987. The next value is 0.626. You'll not find 0.6 thousand, so the closest value to that is 0.5987. The corresponding value of the z of this value is 0.25. So a minus 20 over root of 12 is equal to negative 0.25. Why you have to write negative? Because it's less than 0.5, so you're supposed to write a negative. Less than. Negative is 1 minus table value because we did 1 minus. Then you do cross multiplying and you move negative 20 to the other side. So negative 0.25 times root of 12 plus 20. Then a is equal to negative 0.25 times root of 12. Then you close the bracket, plus 20 is equal to 19.13. This is the random variable. Same thing here, probability of z more than b minus 20 over root of 12. And here is, alhamdulillah, the value is more than 0.5. So you don't have to subtract that from 1, 0.6915. More than and table value, so you're supposed to give a negative sign as well. More than and table value is positive as for the negative. For the positive value, more than the positive, you're supposed to do 1 minus. Now let's check the value in the table, 0.6915. You have this value in the table, 6915. Yes, it's on the line of 0.5, the first column, 0.50. So B minus 20 over root of 12 is equal to 0.50. But you're supposed to add a negative sign because it's more than negative is table value. So you do cross multiplying and you move that to the other side. So A is equal to negative 0.50 root of 12 plus 20. Let's do that on the calculator. Negative 0.50 bracket square root of 12 plus 20. It's equal to 18.267. So you can round it to 2 decimal places as 18.27. Last part, write down probability of B less than X less than A, which means probability of B is 18.27 less than X less than A, which is 19.13. That's it. If you want to find the value of this, basically you have to take the difference. So you do probability of X less than 19.13 minus probability of X less than 18.27. So you have to back to the table value again because those values not on the table. So you do probability of Z less than, for 19.13, the corresponding value of the Z is negative 0.25 minus Z less than, the corresponding value is negative 0.50. Less than negative is 1 minus table value, so 1 minus the table value of 0.25, we'll write 0.6000, and then 1 minus the corresponding value of this, 0.6915, and you do that once on the calculator. 1 minus 0.6 is equal to 0.4, of course, minus the bracket of 1 minus 0.6915. So you'll find the answer as 0.0915. Thank you.